Hello everyone. Today I will give you a trick on how to graph absolute value function in vertex form or graphing forms. What's going on is we have an equation and we're supposed to graph it. The equations that are given to us, the equations that we're going to have in the next examples are actually in vertex form or graphing form. So we can, we remember that the h and the k are the coordinates of the vertex, or we call it as the locator point. And then the a here is our stretch factor. And then if the a is positive, then the absolute value function is going to open up. If a is negative, then it's going to open downward. So let's have this first example here. So we're given an equation y equals negative absolute value of x plus 3 minus 1. So we remember that we need to determine first the vertex, and we remember that the h here is a positive. So that means I'll give you the fast trick on how to determine the h and k, but I'm going to show you the whole process here, the math way. So this is negative of the absolute value of x minus, so that means our h was actually negative 3, so that it came out to be positive 3. So which means that this is our h and this is our k. So that is the h and that is the k. Since both are negatives, that's how it came out to be. Positive, because we have a negative and a negative. Okay, so the vertex that we have is negative 3 and negative 1. So negative 3, x is negative 3 and negative 1. So it's going to be over here. So that's the vertex. Now, I'll give you a fastest way to determine the vertex. I'm going to write the vertex here. The fastest way is we switch the sign of this. So that is a negative 3. And then keep the sign of this. So that is a negative 1. Again, switch the sign, keep the sign. So negative 3, negative 1. So that's the vertex right there. Now, in order that we can determine the second and the third dot, I'm gonna put the trick that we have up here. So I put the little trick on this post-it. So the trick is to determine the second and the third dot. So we're going to use this equation right here. This is like the parent equation for absolute value function. So the x here would represent the steps to the right, that is over from the vertex, and then the y here will represent the steps either up or down, and then the a is the stretch factor that we got over here. So let's find the second dot here. So I'm gonna label here second dot. Okay, so from the vertex, we are going to look for the second dot. Where does it go? So to do that, I'm going to move one, or I am going to go over to the right one step. Okay, so I'm going to go over one step to the right. So using the equation that is the one that we have here, y is equal to a absolute value of x. And this one that I have here will be put into the x. So I'm going to put that in there. So that is y is equal to our a is negative 1. Absolute value of, I put the 1 right there. So, oops, I'm going to use the red for that. So that's 1 right there. So then this would come out y is equal to negative 1. What does it mean? We are going to go down 1. So that's what the negative 1 means. So what it's trying to tell us is that from the vertex, we go one step to the right and we go down 1. So this is the second dot. To get the third dot, we do exactly the same thing. So I'm going to show the third dot over here. So we go over or right 2. So we're going to do 2 from 1, then we go 2. And where do you think is the dot going to sit? So that's over or right 2. So we go ahead and write the equation. This equation that we have over here, y equals a absolute value of x. And then again, this 2 is going to, we plug in the 2 to the x. So this becomes y equals, our a is negative 1, and then absolute value of 2. So then we have y is equal to negative 2. So that means we go down 2. So right 2, down 2. Right 2, 1, 2, down 2, 1, 2. So this is where the other dot is going to sit. And then since there's an axis of symmetry over here and it's symmetric on the other side across, so the other dot is going to be here, and then the other dot would also be here. And so from here we can draw the absolute value graph, and then we are going to put arrowhead at the end of the line to tell us that it's going to infinity. Now you can do the third dot, fourth dot, fifth dot, but we can, once we already have 3 dots over here, we can just connect them to get the line. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the first example. I'm going to put the trick here because we're going to use that in this problem right here. So our vertex, just by looking at this, our vertex here, switch and keep. So that is a positive 2 and then negative 4. So I go to a positive 2 on the x and then negative 4. So I go down. So this is the vertex. And we say that this is going, this is directed up, or it's opening upwards, since that is positive. So then we are going to use the trick to get the second dot. It's exactly the same thing as what we did in the first example. So the second dot would be y. So we're going to go over or right 1. So I go ahead and say y is equal to a absolute value of x, and then the one that we put into the x would be the 1. So then y is equal to, our a was 3, and then absolute value of, we put in the 1 here. Oops, then we put the 1 right there. So 3 times the absolute value of 1 is 3. So what does it mean? We go up 3. So right 1 up 3. So right 1 up 3. 1, 2, 3. So this is where the second dot is going to sit. And then we solve for the third dot. So the third dot is, that's going to be over or right 2. So right 2, then we see where should that dot sit. So we use the equation again. So that is y equals a absolute value of x. And then again, the x that we put in here is 2. So y is equal to, the a here is 3, and then the absolute value of, we put in the 2 here, so that is equal to 6. So what does this mean? We go up 6. So right 2 up 6. So from the vertex, 1, 2, 1, 2, 3, 4, 5, 6. So this is the next dot. So then these are symmetric. So that's 1, 2, 1, 2, 3, 4, 5, 6. So this is symmetric. So we're going to go ahead and put the other dot here, and then the other dot right here. And so from here, we can connect the dots together to create the graph of this absolute value equation. So this is the graph of that equation over there. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example right here. So again, to find the vertex, we are supposed to switch and keep. So that would be 1 and negative, that's a positive 5 because we keep. So that would be 1 and 5. Switch and keep. So that's a 5. So 1 and then I go to 5. So this is our vertex. So we are going to look for the second dot. It's exactly the same process that we did. So first we are going to write down, that is, by the way, over or right. Okay, so I'll give you a trick when we have a fraction. For over and right, you're going to pick a number that is divisible by the denominator 3. It is very important that we put a number that is divisible to this so that we don't get a decimal. So we don't have to approximate where the dot is sitting. So the divisible of 3 would be 3 and 6 and 9. So we can do that. But we're going to do the first two. So over or right 3. So that would be y. We're going to use that equation over there. Y equals a absolute value of x. And then again, the 3 is going to go to the x. So this will come out y equals, that's negative 2 over 3 absolute value of 3, which is the x. So we're going to multiply them across. So that would be negative 6 over 3. So our y is negative 2. What does it mean? We go down 2. So write 3 down 2. So write 3 from the vertex. 1, 2, 3, down 2. 1, 2. So this is the second dot. To get the third dot, we do exactly the same thing. But again, if the a comes as a fraction, you have to look for the over and right would be the number that's divisible by the denominator. So the next number divisible by denominator, 4 is not, 5 is not, but 6 is. So we go ahead and say over 6 or right 6. So then we use the equation again. So that is y equals a absolute value of x. So then we put in the 6 over there. So this is y equals, our a is negative 2 over 3 absolute value of 6. So then this comes out to be y equals negative 12 over 3. So our y is negative 4. What does this mean? We go down 4. So write 6 down 4 from the vertex. So write 6, 1, 2, 3, 4, 5, 6. And then down 4. So again, 1, 2, 3, 4, 5, 6, down 4. 1, 2, 3, 4. So this is the, that's the third dot. So we do exactly the same thing here on the other side. That's 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. So this is the dot. And then again, we go 6 and down 4. So from the vertex, 1, 2, 3, 4, 5, 6. And then down 4. 1, 2, 3, 4. So this is where the third dot is sitting. And so from here, we can connect the dots together and put an arrowhead at the end of the line. And this is the equation for this graph. This is the graph for this equation right here. Did you get the same graph as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!